Hi, my name is Matthias Hurd, and for my semester research project, I decided to look at software testing and why finding bugs early can save both time and money. I chose this topic because bugs are something that pretty much every software project has to deal with. What interested me was not just how bugs are found, but how, when they're found, and how they're tested for can make a major difference. The problem. Starting with the problem, software defects can affect reliability, increase development costs, and obviously create a worse experience for the people actually using the software. That's where software testing comes in. The goal is to identify these problems before the product reaches users. In the paper, Role and Importance of Software Testing and Software Quality Management, Jinyang Jia explains how software testing plays an important role throughout software quality management, rather than simply being something done once development is basically finished. This was one of my main ideas that shaped the rest of my research. 2. Why test early? That leads into the main idea behind my infographic. Why test early? A bug that discovered early can usually be dealt with before it starts affecting other parts of the software. But if the same problem survives into later stages of development, fixing it can become much more difficult and costly. In the same paper, Jia explains that defects introduced during earlier stages can expand as development progresses, which increases the cost of correcting them later. So basically, the earlier you catch the problem, the less you may have to undo later. What the research shows. For my literature review, I focused mainly on 3 research works, which looked at software testing from somewhat different perspectives. The first was Gia's paper on software testing and quality management, which emphasized software quality and early defect detection. The second was the impact of defect reprediction on software testing by Murakami and several other researchers. Their study examined defect prediction and reprediction as ways to identify areas that may contain defects and better direct testing resources. The third was defect detection efficiency, a combined approach by Rashmi and Suma. This study compared conventional scripted testing with an approach combining scripted and exploratory testing. Testing approaches. The last study was particularly interesting because it showed that there isn't necessarily one perfect way to test software. Scripted testing uses predefined test cases, making the process structured and repeatable. Exploratory testing is more flexible and allows testers to use their knowledge and experience as they learn about and test the software. Rather than simply arguing that one method was better, Rashmi and Suma combined scripted and exploratory testing to see whether the strengths of both approaches could improve defect detection. Defects detected. The results from that study are shown in the table on my infographic. Across all 4 projects, they examined the combined testing approach detected more defects than conventional scripted testing. For example, in Project 2, the number of defects detected increased from 251 with scripted testing to 851 with the combined approach. And in Project 4, it increased from 1,022 to 1,644, which means the combined approach detected 622 additional defects. To me, this was one of the clearest examples from the research of how the testing strategy itself can make a difference. My evaluation. After looking at these studies together, my biggest takeaway is that effective software testing shouldn't depend on just one technique or happen at only one point in development. Gia's work emphasizes the value of detecting defects early. Murakami and the other researchers show how defect prediction can help focus testing efforts, and Rashmi and Suma demonstrate the potential benefit of combining different testing approaches. Based on those findings, my evaluation is that effective testing is not necessarily about doing more testing, it's about testing earlier, focusing your effort in the right places, and using methods that complement each other. Future of testing. Finally, the part I found most interesting was where software testing could be going next. Toward the end of Gia's paper on software testing and quality management, future developments include greater automation, closer integration between testing and DevOps, and more intelligent testing tools. The paper also discusses that tools that could automatically generate test data. I found this interesting because it moves testing away from the idea of being one final step before release. Instead, testing can become something that happens continuously throughout the software development process. Conclusion. Overall, the biggest thing I learned from this project is that software testing isn't really about finding bugs. It's about finding problems early, focusing testing resources effectively, and choosing approaches that can uncover different kinds of defects. The research I reviewed suggests that catching defects earlier can reduce unnecessary rework, while effective testing strategies can improve the number of defects detected before software reaches users. And ultimately, that's the idea behind my title. Finding bugs early can prevent much larger and more expensive problems later. Thank you.